to welcome you to our webinar, A Swiss Solution Towards Repair of Composites. At CompPair, we believe in a world without material waste. And what we quite like to start with is the fact that human beings like you or me are able to live for 80 years. But most of the products we use every day last only a few years. This is a paradox, no? And for us, that's exactly how it started, being inspired by nature to extend the lifetime of composite structures. So for today, we will run this presentation on CompPair products. You will see live demonstrations of CompPair composites as well. Then you will have a small questionnaire to answer before going to the Q&A session for an unlimited amount of time. I'm here standing, I'm Amael Coad, CEO and co-founder of CompPair Technologies, and here with me we have today Robin Triguera, CTO and co-founder of CompPair, who will run with us the live demonstrations.
Exactly, and I will let you present the rest of this presentation, and I'll see you later for the live demo.
Great, thanks a lot. So if you're all here today, it's because you're aware of composites and the great potential and the great applications that we can find with composites thanks to their lightweight properties. However, with composites, during their lifetime, you have some problems, first of all, of design limitations because they are sensitive to damage, and then you have the choice. Either you can repair the damage that will appear to composites, and this is a cumbersome process that costs really a huge amount of money, and the global industry is really enormous. Then on the other side, and this might be your case as well, for many applications, what you would do is just replace parts. This generates a very high amount of waste that for many of them are not recycled at all. So this raises big question of lifetime management on one side and sustainability on the other side that we are answering with CompPair by bringing those solutions and reduce your maintenance cost and help the environment. What we are bringing as a solution is textiles, carbon glass textiles that are pre-impregnated with our resin chemistry, and it's more than a prepreg. It leads you to a smart composites. So what you will do with those prepregs is first manufacturing them, producing full composite parts with our prepreg products, and what we aim for is to have a full compatibility for you on your manufacturing line. Then, of course, then what we are bringing when you will produce those composites is a better crack resistance, and you will have the ability to fully regenerate the damage multiple times, and most importantly, extremely fast. At the end of life, and this is why we are providing a 360-degree solution, is an improved recycling. To demonstrate such technology, what we have done is to run several demonstrations, but specifically that one, which is typical of the aerospace industry. We impacted it, and here you are able to see a typical damage. So for you, this might be critical, and we know that this is critical because it will just grow into a larger damage. And you will spend normally several hours to repair it with our solution. This is simple, 150 degrees for 1 minute, and it's done. You recover fully the mechanical properties. With such technology, we are bringing now those prepreg products. This is the first product family that we have as carbon or glass fiber prepregs pre-impregnated with one typical resin chemistry, and here I have an example of those prepregs that are twill or UD glass or carbon textiles. For you, what you have is a standard manufacturing that we are providing with this first family of product of 140 degrees for 3 hours. Of course, this is a first product family, and what we aim for with this technology is to target the entire applications that you can find with composites, and those are just typical examples where we could implement CompPair at a later stage with all our different families of products. So now I think it's time for you to just go for a demonstration to see it from directly your eyes. And what we will do for this demonstration is go, first of all, on a first step, an impact that will be made with a steel pétanque ball, and then run the assessment of damage thanks to an NDT machine or visual assessment, and then at the end, the repairing process that takes only 1 minute with our case, and then we will assess how damage is healed thanks to that on carbon and glass. And for that, what I will do is just go for the other camera. So we will shift the camera right now so that you can see the demonstration and Robin running those demonstrations. So.
Okay, so I have here the glass plate and here the carbon plate. I will impact them, as Omel said, with this steel board. I have a small plate to protect the floor as well. Let's not waste more. Let's impact. So normally you will see an impact in this area on this glass plate. I do the same with the carbon plate. I will need just to be a bit more precise this time. And here we go. So I hand the plate to Amel.
Okay, great. I'm just going to take the camera right now to show you the typical suitcase that we have built for that, where you see different plates, but especially different different shapes that we have manufactured, like a corner in here. And what you will be able to see in here is here a typical damage that you can see in here, which is a delamination that will just grow more and more and more. And what we will do now is bring a typical heat gun that I have here in my hand that you can just see. And what I will do is come onto the damage. So you see close the damage, and I will run the heat gun here. And with the heat gun, what you will see is typically here, in less than 1 minute, we will see suddenly that the temperature is well reached on the damage. And when the temperature is reached, what you would see is that the damage has completely disappeared. So I will let you know when the temperature is okay. It's on my screen, it will be green. And we are soon okay. Yes, we are good. So what you see here is that the damage has completely disappeared. So now we handle back the camera here to Robin to assess the damage on the carbon and to see how it goes with the NDT scan.
So I have here the NDT machine provided by Prepreg. I have here a probe with 64 elements. I have put a bit of gel on my plate, the same kind of gel you would put for an echography. And basically we are sending ultrasound and recording the signal we get back from the plate. And it's showing here with this red to blue scale. And when it's red, we have like a strong signal, and we will lose this signal as we swipe over the defect. So I'm swiping the plate, trying to find the defect. Here, you can see it, I have it here. And yeah, we see that it's time-based. So the screen is shifting. What I will do is to record while I swipe over the damage. And this way we will be able to spend a bit more time on it. Okay, now I can save the file. Just need a DAM, maybe can call it this way. You know, it's our damage. I save the file and I reopen the file then. Okay, and here we have the typical L scan, A scan, B scan, and C scan. We'll go on the C scan view to see a bit better. I will enlarge it like this, and I can also zoom a bit on the default. You can see that it has the typical shape. I now select the freehand cursor so we can measure the impact to really assess what is its size. I'm moving the cursor, you can see it here. And as you can see, we are around 15 millimeters of impact. I can give back the plate to Amel so we can clean it before we heat it. Otherwise, we will just dry the gel on it. And you can really recognize the typical shape we had also with the glass plate. And it's also, as you may notice, quite similar size as we have impacted it in the same way with the same pattern code. And now I think that we are almost ready with the plate. It's dry. And yeah, really the beauty of this NDT testing is to see through this carbon. It's a thin plate, but we can still see well the defect. Now we're shifting to amyl, heating the plate. So it's exactly the same process as what we've done with the glass plate. The same heating process is going on. We are increasing the temperature. We heat the fibers and the matrix as well. You may know that carbon is more conductive than the glass, so the heating is a bit different, but the result in the end will be exactly the same. So we just need to heat it up. Then this time we cannot go directly back with the NDT machine on the plate as it's hot, so we will need to wait for it to cool down. It will take a bit of time, so we will continue the presentation after that. And you will see me also with this typical thermometer, check the temperature of the plate while it's cooling down, and I will put it in water at the end to be sure that we effectively reach the right temperature. Okay, so now I think that we can head back to the and I let Amal go.
Great. Hello again, and welcome back in front of this presentation. So you have seen how we can heal most efficiently those composites, and most importantly, extremely fast. But something that can be really important for you is also to see what are the performances of those composites in typical mechanical properties. So what we have done is to assess the mechanical properties of CompPair composites into tensile, into bending properties, but also compression after impact or even fatigue, to see how they perform. And so what we have done is to run those tests, and we just want to present you a few of them in here. The first one is typical flexural properties, where you see here on the left Flexural modulus for CompPair composites, a typical carbon 2-2 twill with various fiber qualities that we have assessed for this graph. And then what we've done is get the comparison with typical industry benchmarks that we could find into various data sheets for typically the marine and sports and automotive industries. And so what you see is that CompPair composites match completely industry requirements. We've done exactly the same for tensile setup. Here you see the tensile modulus for CompPair composites in comparison to industry benchmarks. And then at the end, what we have said at the beginning is the fact that we have a better crack resistance, so better toughness of those composites. And you see here typical toughness value G1C for, again, CompPair composites higher than the industrial benchmarks that we could find. Here, what you have seen is a demonstration of static damage and repair of those damage typically after an impact. However, into typical application, what you would find is fatigue damage, so cracks that are growing over the time due to the different stresses that are applied onto those structures. We have tried and we have done the reproduction of those cases, exactly that onto some tests. And what you see here is a typical modulus on the left for different healing cycles. And what we have done was to take the sample and get some fatigue testing and then see how they can recover damage after they are damaged at a 90% probability of failure. We stopped the test, we healed the samples, we redid the test again, and what you can see is the fact that for standard composites in red, this is failure after 2 cycles. And for CompPair composites, basically, you can highly extend the lifetime of the composites for a lot of time as compared to standard composites. Overall, we've run various tests that are included into a data sheet. We are more than happy to share with you this data sheet after the webinar. Just feel free to send us an email and we will directly send you the data sheet. To finish this webinar, what we want to do is just give you a bit about us as well. We are a young company and we just want to share with you our history, but also our vision for the future. This technology and those new products are based on deep research run at the Polytechnique Fédérale de Lausanne in Switzerland, and we reached a breakthrough in 2018, then assessed the opportunity and scaled up the product, run various demonstrators. We validated the market as well early this year with validation of the product as well and the properties that you have seen in here. And we also got various awards, and especially we just got awarded the Solar Impulse Efficient Solution Label. We are now today in here with you, with our sales, but we are in parallel as well fundraising. We're a young company, and what we want to do is extend the product portfolio to best meet the various application needs that you would have. Most importantly, we are growing right now a wonderful team in a time of crisis, and we really hope that for you as well, it's going well in those difficult times. We were speaking about the different products and the extension of the product portfolio. We are bringing now one first family of product that is adapted most specifically, of course, to high performance marine and sports application, but our aim is to grow this product portfolio in order to best meet the various application needs, and our aim is to grow further in those various applications, and we are already started right now the development. So if you are interested into that, do not hesitate to contact us. We are more than happy to get in touch and to have further discussions to assess the different synergies that we could have. Finally, what you would be interested in, I guess, is to know what we provide. We provide, of course, things from the implementation to the end product. We provide at first the prepregs with various architectures and fibers, but after that, we are also here with you to have custom design, but also contribute to the implementation setup. Then, of course, customer service, but most importantly for such a new product is to provide repairing process support in terms of heating the plate when you would need to get the repair, even if it's really easy, and then also assessing the damage with the NDT machine or simply by visual assessment. With that, of course, we are not just only Robin and myself, we are a wonderful team running all that venture with also Véronique Michaud, scientific advisor, but we have Cecilia also on the side of technology, Camille on the side of business, and we have Bertie and Nicolas that you might have contact with them after this webinar. With that, I would like to close by sharing with you our vision is really to provide with those solutions full circularity to the composite industry, going from the production and use phase that, of course, you are used to, but then you have issues in terms of damage. If damage appears to the matrix, we are able to heal them, reuse the part again. If damage appears to the fibers, we can recycle them, reproduce them again, closing the loop. And such circular economy model have demonstrated the potential to save a huge amount of resources into composites, which is totally in line with the Sustainable Development Goals. So if maintenance costs are an issue for you, if sustainability is a high concern for you, we really hope that you will join us on this impactful journey. We would like to end to thank the different support we have, the different companies we in close touch with, the Composite United Network for their support into this webinar, Prosec as well for the support into the NDT machine. And right before going to the Q&A, let's head back to Robin to see if the damage is well healed onto the carbon plate. Let's shift again the video.
Okay, so we are back. I've applied already a bit of gel on the plate, and we can look also at the C-scan, same as before. You remember this typical shape of the damage we had here. I can swipe over the plate. It's a bit different in terms of color because the intensity changed a bit as it's not completely cold. Have like modified also a bit the gain, but as I'm swiping, you can see that we don't have this typical shape we are looking for. I'm sometimes lacking a bit of gel, I think, but we are really not seeing this default anymore. So we can say that our plate is now healed the same way that it was the case with the glass. And I think that we will directly head back to the Q&A session with Amel.
Great, so we are back in here, and I think this is time you will have a webinar questionnaire that will pop up on your screen. Please answer those small 3 questions for us to have feedback on that, and what we have now is the Q&A session. If you need to leave during this Q&A session and you have a burning question, do not hesitate to request your question or further information simply on my email or on the one of Robin, or simply at sales@commpair.ch. And now what we will have is Bertie from our team joining us in order to moderate this Q&A session. And I hope that you raised your hand during the presentation, and now we will hand over to the question, and we are happy to answer all of them by Robin. Thank you very much to all for attending this webinar, and we look forward to your questions.
Kamel, so if you have any question, you could just raise your hand and I will unmute you. You can start now. Yes, so we have Dominique.
Do you hear me?
Yes.
Okay. Yeah, this is Dominic Stab from IWK in Rapperswil. Many thanks for your presentation. One question regarding the healing. So we all know that the critical thing for composite damage is the break of fibers. And the healing just shows that you will heal kind of the matrix by temperature. So how do you ensure that you really heal also the break of the fibers? What is not so easy in my opinion.
No, we cannot heal the fibers, but we can heal the matrix, and it's really designed to heal delaminations and micro cracks induced by fatigue, for example, and all those beginning of catastrophic failure you will see later on. If you have a delamination and you continue to use your plate, then you will break fibers and get irreversible damage. But even if the fibers are broken, if you heal the plate, you will close the cracks and also get back the load transfer to the fibers around the damaged area, and you'll get back some of the properties.
Yeah, but no, just a fracture, I think. Yeah. Okay, but you're sure that you just heal the matrix? Yeah, that was my question.
Okay.
Thank you.
Thank you very much. So now we have William.
Hi everybody, it's William Delbert from Gunboat Catamarans. Can you hear me?
Hello. Yeah. Hello.
Yes.
Hi guys, nice to see you again, and well done for a fantastic presentation. I think that was well presented and very interesting. I think you know my questions resulting to two areas that are particularly interesting to us in the marine industry. One is, firstly, will you be developing something that can cure at a slightly lower temperature?
Yes.
And I have another question after that, if you don't mind.
Yeah, go ahead.
Go ahead.
Yeah, the second question is, obviously, I've asked you this before in person, but the key thing for us is, even though there's a dent and maybe the resin can be fixed, you know, we still, anything that we care about fixing is usually covered with paint. And the problem is that if this has been damaged, the paint will be damaged as well. So I think that it's interesting that you can fix the carbon underneath or the glass underneath, but at the moment, is your strategy essentially just that the paint will be damaged by the heat repair process and you'll just be cosmetically repairing the paint afterwards? Or are you going to work with paint suppliers in the future to maybe develop a paint that can actually also heal in the same way? I mean, paint can also be made from similar resins, etc. So, you know, what's the long-term strategy there and what you're thinking? Thank you.
Yeah, in terms of long-term strategy, that's what we are doing. That's what we are doing and developing coatings for that. And we have seen already, and Robin has done it for various paints. And Robin will also complement a bit on that one.
Yes, though we know that composites are usually coated with paints or anti-fouling or whatever. And it's really important for us to be able to have this repair without damaging the paint. And if the paint is damaged by an impact or whatever, you will just need to repaint the parts after the healing process. But really the goal here is to not damage the part while we are healing the structure underneath. And of course, for the first question, we are already working on a second type also of resin, which cures at lower temperature and which might fit better some applications.
Okay, thank you. Thanks for your answer. That's all I had.
Thank you.
Yeah, now we have Mohit.
Hi, thanks for the nice presentation. My name is Mohit. I'm from Singapore, A-Star. So I'm a scientist working in the composites, mainly on the Prepreg technologies based on thermoplastics, thermosets. So I have a question with you. Which kind of resins you are using for, I can understand it's a patentable and already patented, but which kind of resins you are using for such kind of pre-preg technologies, and what are the advancement you are doing in this?
You want to go ahead? I go ahead.
You go ahead.
Okay, I go ahead on that one. So
Okay.
the advancement that we have done in here, of course, as you have seen, there are resins on one side that are thermoset, the other side that are thermoplastics. And what we're doing, most of the links and the bonds that you have into such composites in here are thermoset based, but we are providing mobility through some chemistry that has some thermoplastic base into there. And this is the aim of such structures, to do it the right way in order to keep structurality within the structure. And that's what you have seen with the glass plate. At the end of it, when we were handling the glass and the carbon plates that were hot, what we have seen is that they are completely structural. And if you had a part that was just heated and then that just will be completely soft and loose, this would not have an interest for a structural application. And so that's what we are doing here. I hope this answers your question.
Yeah, I have one more question, I think, related to this. So what are the processing technologies you are adopting for this? I'm asking this question specifically because we are also trying to procure such kind of pre-preg technologies, how to develop the pilot scale pre-preg machines and all those things. So are you using the same or any special processing technology to develop such pre-pregs?
No, we are subcontracting this task to a Prepreg manufacturer. We send them our special resin and they impregnate the dry fibers, and they are doing it on their usual lines.
Okay, okay.
And we can really impregnate them into large quantities. We have here just a small, a smaller strip, but basically we can do as many meter squares as you want.
Yes, a roll of Prepreg is quite heavy.
Okay, I think it's quite interesting, and we are also looking for similar application for our composite utility for the, specifically if you are talking about those thermoplastics. So we will be in touch further how we can explore further for these activities. So nice to hear you. Thanks.
Thanks to you.
Thanks to you.
Thank you.
We have now a question from Kashid that has some issue with the mic. So I'm going to ask the question, what behavior do you expect from the healed surface in environment with outgassing and temperature cycling are significant issues like a space environment?
We will run outgassing testing of our material during the heating process this summer to assess this, but we are hoping that we won't have too much degassing or no degassing, but we need to run tests, scientific tests, to be sure that it's compatible.
All right. If you have any other question, please raise your hand.
Okay, great. In any case, do not hesitate to send us questions personally on our emails. We would be more than happy to answer them. I think that with that, we can close the webinar now.
Yes, and also I would just add that if you have questions about the NDT as well, you can send me an email and I may put you in contact also with our partner Prosec if you're interested in their machines as well.
Thank you very much, and we hope that you enjoyed today. Thank you very much for joining, and we are looking forward to the next step with you. Thank you, and have a good day, and stay safe.
Thank you.